record to the cloud, and we should be good. So if everyone will look in the chat just briefly, boom, there is a link to our AGU session. Please check it out when you get the chance. And how about it, Albert? You ready to take over the floor?
Yep, let's see if I can share my screen. Give me a second here. See if it looks. Present. Is that a full screen?
We're seeing your slides, and
Okay.
now only the slides. Yep.
Wonderful. Okay, so let me shrink this box. Okay, right. So as Sean said, I'm going to be talking about the proposal that we just got funded from the ROSES OSTFL program, and for sustaining and improving the health of SunPy. We're very excited about it. The title of the proposal, the title of the effort is Strengthening the Foundations of the SunPy Ecosystem. And myself, out of NASA Goddard Space Flight Center, I'm leading the effort. So very, very quickly, for those who may not know what SunPy is, SunPy project facilitates and promotes the use and development of community-led, free, and open source data analysis software for solar physics based on the scientific Python environment. Before this funding, the SunPy project has largely relied on unpaid volunteer efforts from early career scientists, especially for developing SunPy's core library. And even though we've been this kind of unpaid volunteer effort, a wide variety of science projects already depend on the SunPy ecosystem for data pipelines or analysis workflows. There's a whole bunch of them that if SunPy were to go away, would be really put out in terms of what they're currently doing. So what do I mean by the SunPy ecosystem? Well, we have the SunPy core library, and I list some of the sub packages within the core library here: coordinates, map, net, time series. The net one is to download data. Map and time series are different data types, and coordinates is some of the underlying framework to enable anything that has to touch coordinate systems and coordinate transformations. There are other sub packages as well that I don't bother listing. But the SunPy ecosystem goes beyond the core library. There are a bunch of sponsor packages and affiliated packages. So these are all packages that integrate and are compatible with SunPy and follow the same kind of philosophies and guidelines for what they offer to the community. But the sponsor packages are distinct from the affiliate packages in the sense that the sponsor packages are maintained by the SunPy project and have a basically shared development team. The SunPy developers who worry about the core library also worry about the sponsor packages. So this list may not be up to date, but it's the sponsor packages, for example, NDCube, DRMS for some downloading, file access, SunRaster for dealing with spectrograph data, Sunkit image for some image processing. And there's affiliate packages as well, like the AIA Pi package for handling AIA data, and also here PFSS package, and then some other affiliate packages as well. And this is the ecosystem that we're looking to make sure stays healthy, but also make it even healthier than it currently is. And that's what this OSTFL funding is for. So we have this proposal that was selected for funding. Activities, which I'll go into more detail on the next 4 slides, are improving the technical infrastructure, augmenting the science enabling functionality in these 2 ways that you see here, but again, I'll go into more detail shortly, and providing training and outreach. And when I say outreach here, I'll explain more in the later slide, but I mean both to up and coming graduate students, new scientists, but also just reaching out to even existing development teams, existing packages that aren't integrated into the ecosystem or don't know how to do it, and getting them pulled into the ecosystem, making it the barriers for entry as low as possible. The team for this effort here is composed of 3 veteran SunPy developers. Myself, I'm the SunPy.coordinates primary maintainer. I've also worn other hats for SunPy in the past, but not currently. Stuart Mumford, who's the SunPy lead developer, and Will Barnes, who's the deputy lead developer of SunPy, but also the primary developer AIA Pi, which I mentioned on a previous slide, one of our affiliated packages. So in terms of the activities, the first activity is to improve the technical infrastructure, which in of itself may not be the most kind of outwardly exciting thing, but it really is about how do we make maintenance easier for the entire ecosystem. And maintenance is one of those things where, especially without something like the OSTFL program, very hard to fund. No one particularly is jazzed about funding keeping things going. Everyone wants to develop new functionality, and then a lot of stuff gets maybe abandoned or at least under maintained. And so the idea here is to really strengthen the foundations, as the title of the proposal says, to generate material that will really help people make better packages and make it able for something like the SumPy core team, the SumPy developer team, to maintain both the core library and the sponsor packages. And you can go through all this text here, but basically it's about the tools, it's about common structures, common technical infrastructure, and making sure that anyone who wants to develop an affiliate package can do so with as easy a time as we can possibly make it for them. Next slide is the supporting multi-point observations subtask. And that has to go into what we do on SumPy.coordinates, where we try to enable manipulating coordinate systems and manipulating data to match those coordinate systems. And one of the things we are striving for is to be both accurate and high performing in terms of the coordinate manipulation. One of the things that we have found as we've been developing SumPy coordinates is that various code that's out there and various file metadata that's out there, they take shortcuts perhaps and simplifying assumptions in the coordinate data they provide. And so it's on us to kind of vet that all and to understand where the problems are. And one of the main tasks that I'm glad that we now have funding to actually do is to actively engage and collaborate with mission and instrument teams to verify the coordinate information they provide. To date, even on the volunteer effort that we've been doing this, SumPy has already found issues and identified and worked with the instrument teams for SDO, both AIA and HMI on SDO, for GOES, the SUVI team in particular on the GOES, and for Solar Orbiter, for finding issues with the coordinate systems, finding issues with the coordinate information that they provide, and helping fix them. And just to show off something that I like to show off in terms of SumPy coordinates and what we mean by supporting multi-point observations is be able to transform data. What you see here in the right panel is a EUV image from stereo EUVI, reprojected to be what it would be seen at the same time from where SDO spacecraft is. And then you compare that directly with an AIA image taken from SDO at the same time. And you can see, of course, similar structures from the same the same active region and very similar EUV wavelengths. And so that coordinate information relies on, again, accurately knowing where the SDO spacecraft is, and then making it really easy for a user to transform that data as they need to see what it looks like from different vantage points for direct comparison. The other science enabling functionality is the support for large data sets. As I'm sure everyone has noticed with SDO, but also with new observatories and new missions that are coming online, we're generating a lot of data, very large data sets, very high resolution and very many time slices, high cadence, lots of imagery. And so what we're going to do is to enhance the functionality that we have in SumPy to make sure that we allow users to take advantage of parallelism, particularly the data handling capabilities of Dask. So I grabbed some images from the Dask documentation, just more cartoons. They're not directly relevant necessarily to what we're talking about here, but it's trying to show off Dask, where Dask can parallelize a NumPy array or a larger array concept that's composed of multiple NumPy arrays, and it can perform operations on such large distributed arrays and produce task graphs that then can be distributed across parallel computing infrastructure, high performance computing centers, and so forth. And so the idea here for this task is to refactor the SumPy map data type and its methods, in particular rotate, because we know that people like to rotate images a lot, to be consistent with Dask mechanisms and be able to operate across very large data files and to parallelize those operations. And finally, the fourth task I listed was the providing training and outreach. SumPy already has a decently well-developed example gallery. I showed just the first page of a page that you can scroll down quite a bit. There are examples in all these different categories for plotting data, for reprojecting data, for manipulating data, even stuff with differential rotation and some more image processing techniques and so forth. And the idea is under this OSTFL funding, we can supplement this example gallery, add interactivity using tools such as Binder to make it possible for users to be even more trained, aware even of the kind of functionality that SumPy enables. We'd also be leveraging established infrastructure for education, such as the multi-institution collage program that has that many colleges participate in, to develop content such as these examples, such as tutorials to solar physics graduate students. So they know about what they can do with SumPy and how it can be useful for their research and the work they're trying to accomplish. And importantly, as it goes to the SumPy ecosystem, as I described before, a very important part is to have the funding now to actively reach out to instrument teams and package developers to encourage the incorporation of the functionality they're working on anyway, but into the SumPy ecosystem. Make sure it integrates well, make sure they're aware of existing functionality so that they aren't duplicating and making redundant functionality, and then make it so that other people that may not be aware of the tools that are developed get that kind of awareness and elevate the visibility of everything we're developing in the scientific Python environment. So yeah, that was a quick run through of everything we're trying to do with this OSTFL funding. The recent 2020 senior review highlighted SumPy as a prime example of a community-based development effort that is open to researchers worldwide, including those in developing countries. That's of course something that why Python is great in terms of just being free to access. And the funding from this OSTFL program is the largest injection of funds into the SumPy project to date. We've had various things like the Google Summer of Code and little bits of funding here and there through NumFocus and so forth. But this NASA funding is really great. And this funding will improve the health of the SumPy ecosystem and ensure robust support for the analysis of complex data from next generation missions and simulations. And that's everything. Any questions?
Yeah, that's exciting. The largest influx of cash to SumPy to date.
Definitely 3 years of funding. I mean, a very healthy chunk of funding. We're very happy with what we're going to be accomplished with this. And I'm sure the story goes the same with a lot of the projects currently in PyHC. But we have this, a lot of us, that even the 3 people currently listening to the team, we have to squeeze in the time that we've had in the past. And for me, as the SumPy.coordinates maintainer, some of the stuff that I talked about identifying in terms of the mission teams and finding problems with what missions are providing in terms of metadata has all been, on my own spare time to help track it down. And sometimes that takes like months for me to figure out what's going on, because I just have, an hour here, an hour there, and that kind of thing. And
yeah,
having dedicated funding to be able to go out and say, yeah, I'm going to check these folks' data. I'm going to see whether it makes sense, look for problems, and help resolve them. And so having that dedicated line of funding is amazing.
Exactly. So this is not categorically different from the kind of stuff we would love to do with our PyHC repos. So yeah.
Certainly, I'm hoping that NASA continues to see the wisdom in providing a line of sustaining funding to help people maintain and to keep these vital packages going.
Yeah, what was the proposal process like? I mean, I feel like it's pretty easy to make a case for SumPy needs to live, but I mean, yeah, well, did you have any hardship there?
Oh, no, I mean, it's a standard NASA ROSES proposal. So this was I think a 15-page proposal, if I remember correctly. And we didn't, of course, this is the first opportunity, first time the OSTFL program solicited proposals, and they funded other major libraries such as AstroPy and Xarray and Matplotlib. They all were also awarded funding in the same call. I guess it remains to be seen about whether NASA's going to keep this going. Presumably, once they see that yes, this money being fed into Python is giving returns, then they'll be hopefully happy and hopefully continue to fund it. It was very competitive. I remember it, but they did fund a lot of these major packages. So really happy that they picked SumPy.
You said Matplotlib was one of them. I didn't know NASA was funding that.
I don't remember the details right now. I saw them in the list of people that are awarded. Matplotlib, in the service of, I think, plotting data, data relevant for NASA. I mean, we depend on Matplotlib as well. I mean, Matplotlib is a crucial part of a lot of what people use for plotting. So I think it's Matplotlib with two others, if I remember. Will, do you remember what the details were on the Matplotlib associated?
I was trying to remember that. I think Matplotlib may have been their own, but then there was like Pandas, NumPy, and another one was like there was a combined proposal
right.
with several of them. Yeah.
Again, I mean, the scientific Python, I mean, all these packages, they need funding. So this is really great.
Fund open source.
Yeah, exactly.
Oh, yes.
Yeah, it would be great to get to like a yearly release cycle, like with the Eclipse project, got all their contributors to pitch in or to commit to like a yearly release thing. I don't know if they're still doing that, but having it that way, everybody can stay in sync with, changes and upgrades. But if you get a sustained enough development, then yeah, you get to a common release cycle, which makes it easier to have,
Sure.
things
For some
change, but still.
Sorry, I was going to say for SumPy specific, we do have an established release cycle. We release major releases every half a year, LTS releases every year. Obviously, that's not the same for all the other packages, so it's not quite like synchronized in that way.
Right.
But certainly, and it would be a little difficult, I think, to like try to enforce a explicit synchronization between like NumPy and SumPy or something like that. But of course, we do strive for compatibility across multiple previous versions and that kind of thing. So strict synchronization is not necessary or is not required.
Right, as long as it's backward compatible, then the new things can come in whenever you can bring them in. So yeah.
Hey, Albert, this is Alec. Congrats on the funding there. You may know I've been talking to Stuart and Jim Bednar from Anaconda on the World Coordinate System, the Xarray. We have a proposal in. I'll let you know if we get funded. If we do, we should talk, because I know there are definitely, from the coordinate systems and what you did for MDQ, there's some things to talk about.
Right, and that's one of the interesting questions about, there are some, at least seeming or potential redundancies between what Xarray is doing and wants to do compared to what is being done at NDQ and the WCS support through that. So certainly, places where we can be more common and share things, and obviously learning from each other's kind of experiences. And
yep, it. Yeah, exactly. So yeah, it just depends on if we get funded to tackle that, but just glad that you're able to improve what you have on your side just there by itself. So it's good either way. But yeah, if we can hopefully discuss that, I think it'll be a cool thing to do. But yeah, super happy to see. I mean, gosh, I remember SumPy talking to Stuart going over to Europe like 10 years ago. Like, dude, it's come a long way. So I'm glad to see it's gotten some serious funding here. It's really desperately needed, and maybe be a point software group really for the rest of the community to follow here. So it's exciting. So right on. Thanks.
Yeah, I wanted to ask you something too about the time series. Oh, sorry. Go ahead.
I was just a quick comment. I will put up a link inside the chat for those that didn't see it, that shows the selections for this OSTFL call. I think there's 8 proposals that were selected out of 61 that were submitted or something like that. I don't know what I don't know what the quality, whether all 61 were of comparable quality, but certainly the 8 they picked were all, I think, all well-known packages that, of course, all could use funding. Sorry, you're going to ask a question?
Yeah, I'm helping out with this effort in the kind of the time series side of the house with interface mechanism called HAPPY, Heliophysics Application Programmers Interface, and it serves out time series data. We have a small, very small funded effort to try and make it compatible with some SunPy pieces. The person we were going to have work with us on that, we ended up not being able to fund them. And so that effort's been delayed by a year. So I'd like to talk to you about that. Maybe we can stay on afterwards to see
Sure.
how we could do that. But in general, for everybody, it's like there's time series elements in SunPy, and we have a time series data delivery API that different data centers are trying to adopt. So there's another area where we should try to focus on some convergence, and especially if you're funded to look at refresh issues or systematic issues, this would be a great time to do that. So
yeah, I completely agree with that. And I will admit that SunPy time series is relatively underdeveloped compared to SunPy.map. A lot of the energy has gone into supporting imagery and that
of
kind
course,
of
yeah.
But certainly we would like to see SunPy.time series get really that same kind of like love and attention. And if it means that we have to take we have to make some significant changes to make it so it's like, broadly integrated with what other people are doing as well. I mean, I think we can easily entertain that sort of thing.
Sure, and there's multiple efforts on that front in PyHC. I see Russell on here as well. He's got some stuff, and Darren's been working with the CCMC to do, model data comparisons, and there's a lot of different pieces. Eric Grimes with the PySpeedas folks. So there's a lot of different things that as if working all these little interfaces between the different packages is part of the issue, keeping that as efficient as we can. But if people can be at least aware of what other folks are doing and try to help keep it integrated, keep the number of different types of things down as low as possible, then I think that helps. So yeah, this is a great win for you guys. It is pretty cool.
Thanks. Yep, I agree.
I was actually just a little bit curious, specifically when you talked about the parallelization improvements. Do you know how much you're going to be able to get out of Dask? Like, are you going to be able to support nearly infinitely large data sets, or is there a cap there?
I guess that's a better question for Will. Glad that Will's on board. Will's connected. Will?
So yeah, I think the our current thinking is that the scalability would be handled by Dask. So I mean, but I think the range of kind of systems that Dask scales to is quite large. Anything from your laptop or your multi-core desktop all the way up to something like the Pleiades supercomputer that NASA operates. So I think our main kind of roadblock at the moment is not necessarily the scalability of Dask, but like our ability to interoperate with things like the rotate function that Albert mentioned in his slides, to our ability to interoperate with Dask and to have basically workflows that respect the lazy evaluation that Dask uses to build up these task graphs. So, I don't see the scalability on the Dask side being kind of our main stumbling block in that part of the effort.
Good stuff. Good stuff. Thank you.
Doesn't sound like there's any more questions. So
Yeah, I was gonna say, if no one has any further questions, I didn't have anything else in the telecon, so we might just end our regularly scheduled programming a bit early this morning or afternoon, I guess, depending what part of the world you're in.
Yeah, I just had a quick follow-up question for Albert. Has your roadmap been updated with this material as well, just on your repo there?
Definitely not.
Okay, all right, thanks. No, I just
Part of the funding.
a place to track
Yeah,
it.
it's part of the funding. That's right.
Yeah, get
Um,
on it.
Yeah, we should.
Okay, cool.
Yeah, I think one of the things we'll find with this funding is we can actually like regularly update things and keep them. Yeah, we'll
No,
get to
no, understood. Yeah, no, I'll just use the link that Will provided for now as a reference for me, but looking forward to the roadmap. So I'll just go to websites. Okay, cool. Thanks.
All right. Well, everyone, like I mentioned at the top of the hour here, this was our last telecon for 2021. So you guys get a short one this time, and we'll go ahead and disperse. Be checking your email for announcements from Julie regarding when we're going to start back up in 2022. And don't forget AGU.
Thanks, Sean. See you guys.
Yeah.
John,
Can
wants
you
to-
stay on?
Yeah.
Yeah, can you stay on? Sure. Or Sean, if you leave, can you like assign one of us to be the host, or
Oh, I can certainly
you're-
do that. Let me
you're welcome to
stop
stay. There's
recording.
nothing secret. It's just
But I don't need
Or-
to be recording this extra bit. So here.
oh, right, yeah.